Alright, the next lesson here is on Pythagorean identity, and we're going to be solving trig equations that are in quadratic form. So first, for our Pythagorean identity, start drawing our circle here. Okay. And draw our triangle in the first quadrant. Right triangle, here's theta, here's the r, y, and x. Okay, now our definitions, our trig definitions, we saw at the very beginning of the year. We had sine of theta is equal to the opposite of our hypotenuse, or y over r. The cosine of theta is equal to the adjacent over hypotenuse, or x over r. We're going to start with that there, or just those two. And those are just definitions we had at the very beginning of the year. Now, I'm going to do the Pythagorean theorem here in terms of these three variables. So Pythagorean theorem says that this leg squared plus this leg squared is equal to the radius squared. Okay, remember this is the obviously Pythagorean theorem. Now, I'm going to do something here. I'm going to divide both sides of this equation by r squared, and you'll see why in a second. So divide everything by r squared, left with x squared over r squared plus y squared over r squared is equal to 1. All right, I'm going to rewrite both of these terms here as fractions that are squared. Right? Now these are equivalent. If you have a fraction, you square it. You square the numerator, and you square the denominator. So this will be x squared over r squared, is what we have there. Okay. Now I'm going to make a substitution. I see I have x over r squared. Well, cosine of theta is equal to x over r. So when you substitute cosine of theta in here, and substitute sine theta for y over r here. So now I have cosine of theta squared plus sine of theta squared equals 1. All right, last step here. Cosine of theta is just like a variable. Cosine of theta, you want to square it. So it means whatever theta is, you take the cosine of theta and then you square it. But it's written like this. We write it as cosine squared theta, and we say it in that order, cosine squared theta, just to avoid confusion, because if you put the square right here after the angle, it's confusing. Do I square the angle, or do I take the cosine of the angle and then square it? Well, to remind you that you take the cosine of the angle and then square it to in between the s and the theta. Plus sine squared theta is equal to 1, and that is the Pythagorean identity. Ta-da! That's the big one. That's mucho important. You'll see it often written as sine squared plus cosine squared, but it doesn't matter because addition is commutative. Okay. All right, so this is the big identity, the one that you got to know right like that. Okay, it's not something, actually, our textbook, I like the saying they had. It's like, you don't memorize them, you need to know them like you know the back of your hand. Okay, you don't memorize your name, you know your name. You need to know this identity, not memorize it. It's got to be that easy for you. Okay, there's alternate forms. So let's say I was going to divide everything by cosine squared. Say, why, Mr. Pines? Well, you'll see. So I'll divide everything by cosine squared theta. That's fine, we can do that. Sine over cosine is tangent. So sine squared over cosine squared is tangent squared theta plus cosine squared divided by cosine squared is 1 is equal to 1 over cosine. 1 over cosine is secant, so 1 over cosine squared is secant squared. Secant squared theta. And there's the next one that you need to know, not memorize, but know. This is also a Pythagorean identity, just different form, right? It's wearing different clothes. It's not different value, it just looks different. Tangent squared theta plus 1 is equal to secant squared theta. So that's the next one you need to know. Very important. Okay? Starting with our identity, or our Pythagorean identity again. Okay, just write back to sine squared plus cosine squared equals 1. Okay. Say it as you do the notes. Sine squared plus cosine squared equals 1. The more you say it, the more you'll memorize it. Or, sorry, not memorize it, learn it, know it. We're going to divide everything by sine squared this time. Sine squared divided by sine squared is 1. Cosine over sine. Cosine divided by sine is cotangent. So cosine squared divided by sine squared is cotangent squared theta. 1 over sine is cosecant. So 1 over sine squared cosecant squared theta. And there's your third version of the Pythagorean identity that you need to know, like the back of your hand, or like you know your name. You don't memorize your name, you know your name. 1 plus cotangent squared theta equals cosecant theta. So those three Pythagorean identities that we've bubbled, you need to write them all in one spot. Big box around them, star, 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 Pythagorean identity. Know that. All right, so our first example is going to be solving this trig equation. We're going to find all solutions when theta is between 0 and 2 pi. And before we start, I was thinking about that Pythagorean identity because it's so good. I always think about it. And it kind of reminds me of the movie series Bourne Identity. You ever seen it? Like Matt Damon plays Jason Bourne, like a super secret spy doing crazy stuff. Maybe someone made a movie called The Pythagorean Identity. I'm not really sure what it'd be about. Probably not as exciting, but anyway. Speaking of Pythagorean identity, hopefully someone makes us some nice posters about Pythagorean identity. You put them on the wall. Probably be pretty important. Hint, hint. All right, so let's get to work here. You need to recognize, you better recognize structure in math. You need to recognize that we have a variable squared and a variable to the first power. This is the same thing. Let's say I made a substitution here. I said sine of theta equals x. So now I have sine squared. If sine of theta equals x, then sine squared is x squared. I have 2x squared minus 3, instead of sine theta, x plus 1 equals 0. And now hopefully you recognize this now. Oh, this is a quadratic. I can usually factor this. If I want to solve for x, I can factor. If it doesn't factor, then quadratic formula always works. We can try factoring right now. Let's see. Put my parentheses out there. Trial and error method here. Something times something makes 2x squared, so 2x and x. Two numbers multiplied and be positive 1. They must both be the same sign. They're both positive or they're both negative. They add to negative 3. It means they're both negative. Okay, well, these two numbers multiplied by 1 don't really have a whole lot of choices here. How about 1 and 1? Good. So, I have 2x minus 1 equals 0 and x minus 1 equals 0. Which means x is equal to 1/2 and x is equal to 1. But we aren't solving for x. We made a substitution. X is sine theta. So we need to go back there and say sine of theta equals 1/2 and sine of theta equals 1. Now, what is theta from 0 to 2 pi? Well, the sine of something is 1/2. Well, that angle is from 0 to 2 pi would be pi over 6 in the first quadrant. Sine is also positive in the second quadrant, so 5 pi over 6. And then it's negative in quadrants 3 and 4, and then after 2 pi, you can't use it. So that's it for this side of this equation. When is sine equal 1? Well, it's pi over 2. And then that's it from 0 to 2 pi. And usually you write your answer in nice little fancy curly braces here, go off to the side. And you're usually supposed to go in order from smallest to biggest. It's just how math is done. Pi over 6. This is 3 pi over 6, which is smaller than 5 pi over 6. So pi over 2, and then 5 pi over 6. All right. This example here, again, we're trying to find solutions from 0 to 2 pi, and mentioned earlier about recognition, about patterns. You need to recognize patterns in math. You need to recognize the situation, the form. You better recognize, right? You better recognize. you have cosine theta here, which is a variable. We don't know what theta is. We have sine squared theta, another variable, but it's squared. Whenever in math, anytime in mathematics, you have a variable to the first power, right? If there was an exponent here, it'd be a 1. And a variable to the second power, you need to be thinking of factoring or quadratic formula. Now another little wrinkle of this problem is one of my favorite problems actually. We have cosine theta and we have sine squared theta. Those don't match up. It's kind of like having an x and it's kind of like having x and y squared. Okay, we want the same variable. But now that we know our Pythagorean identity, let's write that up over here. We can make a substitution here and fix this problem. Cosine theta, I can't really do much with cosine theta. I can make it 1 over secant. That's not going to help. I can't really do it. There's no identities I can fix cosine theta with. But sine squared, I can rearrange our Pythagorean identity so I can change sine squared into something that has cosine squared theta in it. Instead of something which is an expression, I can change this to an expression that has cosine squared theta in it. So I'm going to solve for sine squared theta over here, my Pythagorean identity. Sine squared theta is equal to 1 minus cosine squared theta. Now when I say you need to know Pythagorean identity in all its forms, that doesn't just mean the tangent squared plus 1 equals secant squared, and the 1 plus cotangent equals cosecant squared. You need to also realize that you can take this Pythagorean identity and rearrange it for any term. So here's my substitution. 1 minus cosine squared theta is going in for sine squared theta. 3 cosine theta plus 3 equals 2 times the quantity of 1 minus cosine squared theta. You're going to make a substitution like this a lot in the upcoming month here for class. You'll do this a lot. 3 cosine theta plus 3 is equal to distributive property. Love distributive property all day, every day. 2 minus 2 cosine squared theta. Okay. Again, when I say you better recognize that you have a variable to the first power, variable to the second power. They're both the same variable. You need to get them on. You need to get everything on one side of the equation before you can factor, or use quadratic formula. Everything must be on the same side of the equal sign. We'll see. I want my squared variable to be positive, so I'm going to add 2 cosine squared theta. And then plus 3 cosine theta. I have a 3 here. I need to get this 2 on the left side of the equation. Subtract 2. 3 minus 2 is plus 1 equals 0. Okay, got all the same variable. Everything's on one side of the equation. I can factor now. It's kind of like the last problem. Easy factoring right now. There'll be some more complicated factoring, so don't get too bored with this problem. They're not all going to be this easy. 2 cosine theta times cosine theta makes 2 cosine squared theta. Two numbers multiplied to positive 1 must be the same sign. They add to positive 3. They're both positive. Not too many options here. 1 times 1 makes 1. Okay, so 2 cosine theta plus 1 equals 0. Cosine theta plus 1 equals 0. Cosine of theta equals, so you subtract 1 divided by 2, negative 1/2. Cosine theta equals negative 1. Okay, so theta must be cosine's negative 1/2. See the second quadrant, that would be 2 pi over 3. And also in the third quadrant, so 1 pi over 2 pi over 3, 4 pi over 3. Over here, cosine of what angle is negative 1? That would be pi. And from 0 to 2 pi, that's all we have. 1, 2, 3 answers. Let's write them in order. There are little squiggly curly braces here. Smallest one is 2/3 pi. And then we have pi, and then 4 pi over 3. And there's your final answer.